All right, guys, here's the second video for 15.1. My daughter's sitting next to me listening to me videotape, and she was just laughing at me. She first said that funner isn't a word, Mom. And then she said, you sound funny because you keep asking them questions like they're going to answer you. I just feel weird talking to myself, so I'm going to pretend like I'm actually talking to you guys. All right. Anyway, we've been talking about antiderivatives. And just like we have derivative rules, we have antiderivative rules. So we've already learned the power rule. Now let's talk about a few more rules. And they're really similar to our derivative rules, where if I have a constant, a number, do you remember what we did when we had a constant in our derivative rules? Oh, that's me asking a question again. We take that constant and we bring it out in front and then just find the antiderivative of the rest of it. Or when we have two different terms and they're separated by a plus or minus sign, what I can do, just like I did with derivatives, is I can find the antiderivative of each piece separately and then just add or subtract them together. But that only works if there's a plus or minus sign. Okay, let's practice some of those new rules. So example number 2, find each indefinite integral. So if 2v cubed is my derivative, what would be my antiderivative? Let's integrate it. Well, if you notice, I have a 2 here, and that's just a number. So can I leave that number chilling out in front? And so if I leave that 2 chilling out in front, then I can just find the antiderivative of v cubed with respect to v. And so using our power rule from before, I can add 1 to my exponent and divide by that new exponent. And so I ended up getting v to the 4th over 4. But remember, there's a 2 still there in front of it. And then also remember your constant of integration at the back, plus c. I would reduce the 2 and the 4, and I would end up with an antiderivative of v to the 4th over 2 plus c. Okay, look at b with me. On b, I notice that there's a variable in my denominator, but remember there is no quotient rule with antiderivatives, so we must be able to rewrite this somehow so that we don't have to use quotient rule. And so I brought that z to the negative 5 up next to the 12, and so I now have 12 z to the negative 5th, and I'm going to find the antiderivative of that. I also noticed that the 12 was just a number in front, so I can bring that out in front. I can use my power rule to add 1 to the exponent and divide by that new exponent, and then bring that 12 back. So I have z to the negative 4 divided by negative 4, that's my new exponent. I brought my 12 back, and I added my constant of integration. I'm going to simplify a little bit because 12 divided by negative 4 reduces, and I ended up getting negative 3 z to the negative 4, but then I dropped that z to the negative 4 down to make them positive. So now I have a negative 3 over z to the 4th plus c. Okay, make sure you understood what I did on all those steps there to get the negative 3 and then the z to the 4th down on the bottom plus c. Okay. All right, C is an example where we have a couple of different terms, 1, 2, 3 different terms, and they're just separated by plus or minus signs. So we should be able to take the antiderivative of each piece separately. I'm going to use my power rule on each of these. I'm going to add 1 to the exponent and divide by the new exponent. Try it. Pause the video, try this one, and see if you get the same thing as I did. All right, I had the 3 out in front that was already there. I added 1 to the exponent and I divided by that new exponent, so I have z cubed over 3. On the next piece, I had a negative 4 that was already there, so I left it alone. I added 1 to the exponent and I divided by that new exponent. So now I have x squared over 2. And then on the 5, we know that the antiderivative of 1 is just x, so now I have a 5x. And then don't forget your constant of integration at the back. Simplifying it a little bit, you should have a final answer of x cubed minus 2x squared plus 5x plus c. Okay? All right, so applying our 3 different rules now to find antiderivatives. The next couple problems are try-it problems. So I want you to pause the video. I want you to try it all by yourself, and then I want you to see if you got the same answer as me to make sure that you understand. And if you're not sure, reach out. Let me know if I can help with something. So on try-it number 1a, I brought it up to the top, made it x to the negative 4. I then integrated using my power rule where I added 1 to the exponent and divided by that new exponent. And then I just moved things around so that I had a positive exponent in the end. I was okay with a negative 3 on the bottom, so I just brought that x cubed down to the bottom as well. So I have 1 over negative 3x cubed plus c. On b, I use my rule that I can take the antiderivative of each piece separately. So using my power rule again, I added 1 to the exponent and divided by that new exponent. I simplified a little bit and I got a final answer of 2x cubed plus 4x squared minus 9x plus c. I hope you guys got the same answer as I did.